Now, new chapter, gravitation. So first we take Newton's law of gravitation. Universal law. Newton's law of gravitation. So Newton's law of gravitation states that every body in this universe attract each other. Body with force, which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. The direction of force is along the line joining the particle. So F means everybody in this universe attract each other, body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. The direction of force is along the line joining the particle. Suppose here we take A and B, two particles. Distance between them is R. The F proportional to M1, M2 upon distance between them is R. The F proportional to M1, M2 upon R square. Then F equal to G M1, M2 upon R square. Here G is the gravitational universal constant. Its unit is Newton meter square per kg square. Dimension formula we write M minus 1 L3 T minus 2. Now we take a vector form. This is a scalar form. So 1 है, ये 2 है. 1 पर कौन फोर्स लगेगा 2. Force on 1 due to 2 is F12 equal to minus GM1 M2 upon R square. Final minus initially, so R21 cap. Attraction force we take minus R21 cap. Minus GM1 M2 upon R cube. R21 in a vector, so R21 cap is equal to R21 vector upon R21 means R, so R cube. So minus GM1 M2 upon R21 vector all cube into R21. Now take F21. Negative sign indicate the direction of F12 is opposite to the R21. So R21 in this direction, force is in this direction. Now force on 2 due to 1 is minus GM1 M2 upon R square into R12 cube. Minus GM1 M2 upon R cube R12. So this minus GM1 M2 upon R12 cube into R12 so is equal to GM1 M2 upon R square into R21. Because R12 cap equal to R21 vector. It is clear F12 equal to minus F21, which is Newton's third law. Okay, G is the constant of proportionality, which is called universal gravitational constant. If M1 equal to M2 and R equal to 1, then G equal to F. So universal gravitational constant is equal to the force of attraction between two bodies, each of unit mass, whose center are placed unit distance apart. So define here G. Now, the value of G is laboratory was first determined Cavendish. using torsional balance. The value of G is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square in SI. In a CGS, 6.67 into 10 raised to minus 8 centimeter square per gram square. यह हमें याद रखना है. Dimension formula M-1 L3 T-2. The value of G does not depend upon the nature and size of the bodies. याद रखना है ये सब. It is also not depend upon the nature of the medium between the two body. बॉडी के बीच में कौन सा मीडियम है उस पर डिपेंड नहीं करता. A G is very small, hence the gravitational force are very small, unless one or both or the mass is used. Now, properties of the gravitational force. ये हमें याद रखनी सब प्रॉपर्टी. It is always attractive in nature, while electric and magnetic force can be attractive or repulsive. Gravitational force is always attractive. It is independent of the medium between the particle, while electric and magnetic force depend on the nature of the medium between the two particles. Third, it holds good over a wide range of distance. It is found true for interplanetary to interatomic distance. It is found true for interplanetary to interatomic distance. It is a central force, is that act along the line joining the center of two interacting bodies. It is a two-body interaction, is that gravitational force between two particles is independent of the presence or absence of the particle. So the principle of superposition is valid, is that force on a particle due to a number of particles is the resultant of force due to individual particle. Is that resultant force is F1 plus F2 plus F3 up to so on. While nuclear force is many body interaction. Gravitational forces, we take only two body interaction. Means ये हमें याद रखना है is that the gravitational force between two particles is independent of the presence or absence of the other particle. So the particle of the superposition is valid. Principle of superposition is valid. Is that force on a particle due to a number of particles is the resultant of force due to individual particle. Is that F equal F1 plus F2 plus F2 so on. While nuclear force is many body interaction. It is the weakest force in a nature. It means सबसे ज्यादा फोर्स न्यूक्लियर फोर्स, उसके बाद इलेक्ट्रोमैग्नेटिक और उसके बाद ग्रेविटेशनल. The ratio of gravitational force to electric force between two electrons is of the order of 10 raised to minus 43. तो इलेक्ट्रॉन के लिए इलेक्ट्रिक फोर्स और ग्रेविटेशनल फोर्स का रेशियो नियर अबाउट मिलता है 10 raised to minus 43 पावर. It is a conservative force, is that work done by it is path independent or work done in a moving a particle around a closed path under the action of gravitational force is 0. Okay, so total round gravitational force is a conservative force. Here we study chapter numbers closed integration of f dot dr is equal to 0, means के round integration of conservative force is 0. It is an action-reaction pair. Is that the force with which one body attract the second body is equal to the force with which moon attract the earth. This is in the accordance with the Newton's third law of motion. This is the property. Now, the law of gravitational is started for 2 point masses. Therefore, any two arbitrary finite size body as shown in the figure, it cannot be applied as there is not unique value for the separation. So here, but if the two bodies are uniform sphere, then the separation R may be taken. So non-uniform, तो सेपरेशन क्या लेना है वो हमें फिक्स नहीं कर सकते, लेकिन यूनिक बॉडी मीन्स के स्फीरिकल बॉडी, then we take a separation between them is fixed. So here we write F equal to gm1 m2 upon r square, but here not right. R क्या लेना है वो हमें नहीं मालूम, क्योंकि सेंटर ऑफ मास कहाँ पर है वो नहीं मालूम. यहाँ पर वो दिखेगा तब हम R ले सकते हैं. A gravitational force between two objects does not depend on sum of masses. Product of mass पर depend है, gravitational constant पर depend है, distance between the mass उस पर depend है. Problem 2. Mass m is divided into two parts. First xm and second 1 minus x into m. For a given separation, the value x which the gravitational attraction between the two pieces become maximum. तो मैक्सिमम और मिनिमम के लिए कंडीशन है डिफरेंशिएशन ऑफ फोर्स विथ रिस्पेक्ट टू वेरिएबल. तो यहाँ पर वेरिएबल एक्स के रिगार्डिंग डिफरेंशिएशन 0 होना चाहिए, 0. तो हियर वी राइट f equal to gm1 m2 by r square, f of x m1 equal to xm, m2 equal to 1 minus xm. तो gm square by r square x 1 minus x. तो put this value, तो gm square x upon r square 1 minus x. This is the constant 0. Then we write d by dx 1 minus x plus 1 minus x into dx by dx is equal to 0. x 1 का डिफरेंशिएशन 0, x का -1 प्लस 1 minus x, x का 1 is equal to 0. तो -x plus 1 minus x is equal to 0. -2x plus 1 equal to 0. Then 1 minus 2x equal to 0. Then x equal to 1 by 2. तो मास क्या हाफ होना चाहिए. दोनों टू पार्ट have a same mass, then force is maximum. So here x equal to 1 by 2. ऐसा ही सब इलेक्ट्रिसिटी में आता है. वहां पर टोटल चार्ज होता है, एक 1 पर Q लेते हैं, दूसरे पर Q माइनस Q. तो कितना चार्ज होना चाहिए कि इसलिए इलेक्ट्रिकल फोर्स बिकम अ मैक्सिमम. देन वी राइट वहां पे Q by 2 और दूसरे पर भी Q by 2. यहाँ पर m by 2 आया है, वहां पर Q by 2 आता है, याद रखना है. The mass of the moon is about 1.2% of the mass of the earth. Compared to the gravitational force the earth exerts on the moon, the gravitational force the moon exerts on the earth. दोनों सेम ही है, okay? Earth and moon both exert the same force on each other. 2 1 पर जितना फोर्स लगाता है उतना ही 1 2 पर फोर्स लगाता है. This is this law. F12 is equal to minus F21. 3 identical point masses, each of mass 1 kg, lie in the xy plane at point 0 0 0 0 0 0 2 meter 0 0 2 meter and 0.20 meter 0.20 meter. And net gravitational force on the mass at the origin. तो this mass पर कितना force लगता है? तो first, let A lie on the origin, the particle B and C, Y and X axis respectively. Then C के द्वारा A पर कितना force लगता है? G m1 m2 upon r square. 6.67 10 raised to minus 11 mass 1 है 0.2 square into in this direction I cap. तो 1.67 into 10 raised to minus 9 I cap meter. तो force on A due to B, force on A due to B is equal also 1.67 into 10 raised to minus joule J cap Newton. So this force in this direction, this force in this direction. The resultant force, so F is equal to under root, we write F AC square plus F AB square. Okay, middle term is 0 because cos 90 is equal to 0. So angle between these forces is 90. So root 2 we write FS. तो in this direction में resultant force लगेगा. Okay, तो √2 into तो हमें मिलता है, सॉरी I और J के फॉर्म में है तो हम ये लिख सकते हैं 1.67 10 is to minus 9 J के प्लस I के न्यूटन और इन मैग्नीट्यूड फॉर्म हम ये लिख सकते हैं √2 into 1.67 10 is to minus 9 Newton. Example 5. 4 particles of masses m, 2m, 3m, and 4m are kept in a sequence at the corners of a square of side A. Okay, the magnitude of gravitational force acting on a particle of mass m placed at the center of the square will be A, B, C, D. Mass here m, here 2m, here 3m, here 4m. The magnitude of gravitational force acting on a particle of mass m placed at the center of the square. सेंटर पर स्मॉल m मास रखा है, इस पर कितना फोर्स लगेगा? तो साइड इज ए मीन्स हाइपोटेनियस 1 3 2 4, तो वो डिस्टेंस है, तो हम लिख सकते हैं कि 1 4 ए डिस्टेंस तो हाइपोटेनियस मिलता है √2 ए स्क्वायर प्लस ए स्क्वायर 2a स्क्वायर स्क्वायर रूट लेते तो √2a, लेकिन वो इसके हाफ, तो x इज इक्वल वी राइट डिवाइड बाय 2, तो a बाय √2 मिलेगा. ओके, so here we write force on P due to A. So G m square by x square. Here we take F. Force on a P due to B. G to B का mass 2m है. So 2m into m by x square means 2m. Force on a P due to C. So G C का mass 3m m upon x square 3m. Force on a P due to D. So G 4m m upon x square 4m. The net force on a P F net equal to FP plus FPB plus FPC plus FPD. So resultant we write here F plus 2F plus 3F plus 4F. F plus 3F, 4F, 8 plus 2F, 10F. 10F. Not right. Okay. तो रिजल्टेंट फोर्स चाहिए. तो रिजल्टेंट फोर्स हम लेते हैं दोनों ऑपोजिट टू ईच अदर. इन दिस डायरेक्शन 3F. इन दिस डायरेक्शन F. तो ये दोनों का रिजल्टेंट 2F इन दिस डायरेक्शन में मिलेगा. ये दोनों का रिजल्टेंट इन दिस डायरेक्शन 2F. इन दिस डायरेक्शन 4F. ये दोनों का रिजल्टेंट मिलेगा 2F इन दिस डायरेक्शन. इन दिस डायरेक्शन ऑल्सो ये दोनों का रिजल्टेंट 2F आया है. तो ये दोनों का रिजल्टेंट दिस एंगल स्क्वायर है तो 90 आएगा. तो दोनों का रिजल्टेंट आएगा तो √2 इंटू 2F आएगा. ओके. अकॉर्डिंग टू एबो हमने लिया था ऐसे तो हम यूज कर सकते हैं. तो रिजल्टेंट फोर्स इज 2F स्क्वायर प्लस 2F स्क्वायर. मिडिल टर्म इज 0. देखो √2 इंटू 2F हमें मिलता है. तो 2√2F. तो F नेट इज इक्वल टू 2√2 F G m स्क्वायर बाय x स्क्वायर. 2√2 GM square x equal to a by √2. Then here we write √2 square. Now take numerator 2 into 2 4 4√2 GM square by a square. ये आंसर मिलेगा. Next point. Acceleration due to gravity. जी की फॉर्मूला मास ऑफ अर्थ के रिगार्डिंग हमें फाइंड करनी है. The force of attraction exerted by the earth on a body is called a gravitational pull or a gravity. We know that when force act on a body, it produces acceleration. Therefore, a body under the effect of gravitational pull must accelerate. The acceleration produced in the motion of a body under the effect of gravity is called acceleration due to gravity. It is denoted by G. Consider a body of mass m is lying on the surface of the earth. Then gravitational force on the body is given by F equal to G capital M small m by R square, equation number 1, where mass m is equal to mass of the earth and R is equal to radius of the earth. If G is acceleration due to gravity, then the force on the body due to the earth is given by force is equal to mass into acceleration, F equal to mg. So mg, G capital M small m upon R square. Okay. So now mm cancel, then G is equal to gm upon R square. Now this is the gravitational acceleration. Now, in a form of a density, we take mass equal to volume into density. volume equal to 4 by 3 pi r cube, density is rho. 4 by 3 pi r cube rho, r square cancel, then G equal to 4 by 3 pi rho gr, equation number 4. From the expression G equal to Gm upon r square 4 by 3 pi rho gr, it is clear that its value depend upon the mass, radius, and density of planet. And it is independent of mass, shape, and density of the body placed on the surface of the planet. Is that a given planet produce same acceleration in a light as well as the heavy body? Okay, तो सबके लिए G constant ही है. The greater the value of m upon r square or rho into r, the greater will be the value of G for the planet. Acceleration due to gravity is a vector quantity and its direction is always toward the center of planet. So dimension G equal to m0 L1 p minus 2. Its average value is taken to be 9.8 meter per second square, या 981 centimeter per second square, या 32 feet per second square on the surface of the earth at mean sea level. The value of acceleration due to gravity vary due to the following factors: A, shape of the earth; B, height above the earth's surface; C, depth below the earth's surface; and axial rotation of the earth. Acceleration due to gravity on the moon is 1/6 of the acceleration due to gravity on earth. If the ratio of density of earth rho m and the moon rho is rho e by rho m is equal to 5 by 3, and radius of the moon rm in terms of r. So rho वाली formula है G equal to 4 by 3 pi rho gr, to proportional to rho r. So gm by g, rho m by rho e, rm by r. Then rho m by rho e is equal to 5 by 3. And gm by g is equal to gm, हमें rm by re फाइंड करना है, तो rm by re सब्जेक्ट बनाते हैं, तो इस रिएक्शन में जाएगा, तो rm by re is equal to gm by g into rho e by rho m. Okay, so here rm by re, so gm by g is equal to, we take 1/6, and g rho e by rho m is equal to 5 by 3. So 1/6 into 5 by 3. Then rm is equal to 5 by 18 re. Okay. 6 into 3, 18, 5 by 18. Next, spherical planet far out in space has a mass m and diameter do. A particle of mass m falling freely near the surface of this planet will experience acceleration due to gravity, which is equal to the particle of mass m falling freely near the surface of the planet will experience the acceleration due to gravity. So now here we write in a form of diameter gm upon r square, r equal to d by 2, or gm upon डी स्क्वेर, तो हमें जी मिलेगा 4 gm/d स्क्वेर, तो आंसर इज सी। Next, 8. The moon's radius is 1/4 the Earth. So R moon is equal to RE by 4. And mass is 180 times the Earth. So M moon is equal to M Earth by 80. If G represents the acceleration due to gravity on the surface of the Earth, that on the surface of the moon, so G equal to gm/r square. So G constant m by r square. Now take moon by Earth. So m moon by m Earth. R denominator में तो r Earth square by r moon square. R moon by r Earth is equal to 1 by 80. And r Earth by r moon is equal to 4 by 1. Reciprocal. 1 by 80 into 1 by 80 into 60. So 1 by 5. So G moon is equal to G Earth by 5. Next, if the radius of the Earth were to shrink by 1%, its mass remain the same. तो रेडियस चेंज करते हैं 2%, मीन्स श्रिंक डिक्रीज करते हैं। The acceleration due to gravity on the Earth's surface would be, मास कांस्टेंट है तो इसलिए हमने मास कांस्टेंट है तो G proportional to 1/r square. Now 2% चेंज होता है 1%, तो हम लिख सकते हैं यहाँ पर डेल्टा G by G is equal to delta R by R. Now multiply G by G into 100%. 2, this is the 1%. So now we take 2%. Okay. तो सिंक मीन्स डिक्रीज होती है रेडियस, तो 2% इंक्रीज होगा, तो आंसर इज सी। Next, mass of moon is 7.34 into 10 raised to 22 kg. If the acceleration due to gravity on the moon is 1.4 meter per second square, the radius of the moon is, to find the radius of the moon, G given 6.67 into 10 raised to -11 meter square per kilogram square. So R equal to gm/g. Now put the value of G, M and R. A planet has a mass 1/10 of that of Earth, while the radius is 1/3 that of the Earth. If a person can throw a stone on Earth's surface to a height of 90 meters, then he will be able to throw the stone on the planet to a height. So here, acceleration due to gravity, G is equal to gm/r square. So G planet upon G Earth, M planet upon M Earth, R Earth upon R planet square. Then N planet by M Earth is equal to 1/10 into 1/3. तो reciprocal है तो 3/1 square, तो 9/10. Then here, if the stone is thrown with velocity u, surface of the planet, then maximum height u square by 2g. So v square minus u square equal to 2ax regarding h. Here we take u square by 2g. Then h proportional to 1/g. Okay. So h planet upon h Earth equal to g Earth upon g planet. So here h Earth is equal to 9/10. Sorry, g Earth by g planet 9/10. So here planet, here denominator में planet है, तो we write 10/9. H earth is equal to 90 meter. 90 99 cancel तो 100 मीटर. ओके, याद रखना है, ऐसे क्वेश्चन आते हैं. प्रॉब्लम 12. लास्ट एग्जांपल लेते हैं और नेक्स्ट लेक्चर we take tomorrow 6:45. The radii of two planets are respectively R1 and R2. Their density are respectively ρ1 and ρ2. The ratio of the acceleration due to gravity. तो हमें मालूम है G is equal to 4/3 pi rho GR. तो G proportional to rho into R. तो G1 तो ρ1 R1 upon ρ2 R2. Answer is D. Okay, तो यहाँ तक रखते हैं. Next lecture I will take tomorrow at 6:45. Clear? Okay.